I flipped these two chassis over so I can use the one as a reference, and I noticed something else. They are not the same. Not only is the socket a different color, but check out the height difference. The one on the left is about 1.5 inches, 2 inches taller. And that's because of the flyback cage. So this one's about this tall, which is considerably taller than that. And the metal mounting strap is similarly taller. So, I guess these are different production runs. I hope that won't cause me any problems. I've been looking through the SAM service info, and I don't see any reference to different production runs. I know in the past Philco would have things like code 123, code 124, code 126 to indicate production run changes. But I don't see any markings on these anywhere, nor do I see that mentioned in either the SAMs or this little pocket service guide here. I'm guessing they have different flybacks in them. The only reason I can think of why the box would be so much taller is maybe the high voltage rectifiers. They had a taller one in this model. The later high voltage rectifiers were shorter like this, but the earlier ones were considerably taller. Although I would have thought by the late 50s they'd all be the short variety. I don't know. I don't know, but from what I can see, the wiring looks to be the same. Same parts in the same location for sure. So I'll just keep my fingers crossed, and as I say that, no, they are not the same. Hey, well, we'll see how it goes. What just caught my eye here, we've got a little terminal strip, 2 posts, and 2 big old ceramic caps here. Does not exist over here. There's one ceramic cap up there. Also notice this big fat wire running here. Isn't over here, or maybe it's this brown wire under here. Alright, well, I guess I'll study my notes a little more closely. And, well, let's see. What do they show here? Chassis bottom view. Okay, yeah, it's oriented the same as mine. They just show the one ceramic cap. It looks like the unmolested set on the left. It matches this. So perhaps this was added. No, I don't think this was added during repairs because it looks like it's welded or riveted onto the chassis. So that must be a production run change. There's a big fat resistor under there too. 560 ohm, I think. And it's not over here. Well, that I can check pretty quickly in the schematic, because that is off the damper tube. Let's see. Okay, that capacitor is this guy here. And notice there's a resistor there with dotted lines. That must be a production run change. 470 ohm at 2 watts. I've got a 560 at 2 watts. That may have been an old repair. Just likewise, these caps. These two were in parallel, but that was to equal the right capacitance. I think they're both 100 and... well, I'm not sure what the value is. All I see on there is a 134 and a 3 kilovolt. Maybe it's on... okay, I see it's marked on this side. It's just so filthy. Can't read it. Figures the sides I'm trying to read are both blackened. Well, at any rate, I'll try cleaning it off. I assume that those two are parallel to equal the right capacitance value. And that resistor may or may not be original. Might be part of an old repair, but for sure that is a production change. So I'll just have to be extra careful. Every time I see something that doesn't match, I'll have to refer back to whatever service info I can find and see if those were production run changes and if they should really be there or not. I'm slowly making progress on restoring the underside of this tandem chassis. I'm starting to think, though, that having this unrestored one next to it is as much of a hindrance as it is a help, because there are production run differences. For example, check out in this set, we've got one electrolytic cap sitting here. In this set, which has been worked on previously, we've got an electrolytic here, big resistor here, and another electrolytic hiding under it. Well, what's all that about? Well, eventually I dug through the schematics and the parts list and realized that if you look at the electrolytic capacitor section in the SAM service info, there are some notes there on the capacitors. If you look down here, it says combined with C6 in late production, combined with C5 in late production. And on closer inspection, I realized that there's actually two caps in here. I had just noticed these two leads coming out, and I assumed that that was a negative and that was positive, and that's it. But no, it's a third lead. On this end, that's the common negative. There are two positive leads. There are two electrolytics inside this can. That's equivalent to these two. Also, notice that here, there's one of those K networks. That's for vertical blanking. It's a little filter network that creates a pulse that goes to the picture tube to blank out the vertical retrace. Or I should say blank out the video during the horizontal retrace period so you don't get those diagonal zigzags on the screen. In this set, it's not there. What I did eventually figure out is that somebody had built one using discrete components, two capacitors and a resistor. However, these aren't quite right. 103, that means 10,000 picofarads and 600 volts. But if you look on the schematic, 10,000 picofarads is right, or 10,000 microfarad, but it should be 1,000 volts, not 600 volts. This picks a signal off the vertical output transformer, and those can be pretty substantial spikes there. So I definitely want to get capacitors rated for 1,000 volts when I rebuild that. Something else I noticed that's a bit different from my holiday set is how they drive this picture tube. So there's a video output tube. Go from the plate, get a choke there, or an inductor, capacitor, and then it goes over to G1 there, pin 3. Well, if I pull out the holiday service info, you'll see that they drive the cathode. So here, the video output plate, capacitor, and it goes over to the cathode. I imagine they made that change. Well, I was going to say they made that change because they had to drive the cable, but there's another reason they may very well have made that change. Is here's the same output tube as in holiday set, and you got your signal coming out. Goes through the cable, then it's amplified inside the CRT housing. This will invert the signal. If you take that inverted signal and go to the cathode, you're going to have an inverted video. Black is white and white is black. But if you drive G1, you'll be alright. I've noticed that in other sets that if they have like an odd number of IF stages, they drive, say, the cathode, and if it's an even number of stages, they drive a grid, just because every time you go through an amplifier, the video signal keeps getting inverted back and forth. And similarly, on the various output stages, they have slight differences. The tubes are biased slightly differently. There's more filtering, or it's just a different tube that has a higher output power. I'm sure it's all to drive that long 25-foot cable and get usable signals at the other end. So we've got a bit more work to do. Down here, and then of course I unmount those two caps and restuff them. I figured I'd better double check the replacement thermistor I found installed here, and I'm glad I did, It's cold right now, or room temperature. I'm getting 23 ohms. It's supposed to be 400. And then when it gets warm, it should go down to just a few ohms. So I'll take my soldering iron here and heat it up a bit. And even if it does go down, still that cold resistance should be much higher than that. So yeah, it's going down. But definitely want to replace that. I don't know what type this is. There's no part number on it or anything. It bottomed out at around 2.1 ohms, which is okay for the hot resistance, but the cold resistance should be about 20 times what I was getting. So, as I was saying, I'll definitely replace that guy. I found some corrosion down in this corner, so I decided to carefully unmount and remove the vertical output transformer. I then unsoldered and moved aside a few wires to open this area up so I can apply some naval jelly rust dissolver. Mostly the rust was around these openings stamped into the chassis. Once I get that cleared out, I'll start putting things back together. Also, I've got some time to kill because I had to place an order with Mauser. A few items I didn't have on hand, including those 0.01 microfarad 1000 volt caps for the retrace K network that goes right here. I want to replace these two caps with one cap. Should be 250 picofarad, 3000 volts. That should be 470 ohm at 2 watts, I think, and not 560 ohms, and so on. So what I'm doing now is I'm quickly going through the rest of this to see if there are any more parts that I don't have on hand that I might need, so I can put together another order with Mauser Electronics. Well, one other thing I found that was kind of curious. So I was working in this area, I found this wire here, stub, just cut off, going to nothing. And I thought, oh, okay, great. When this set was worked on in the past, somebody cut a wire, rerouted it, who knows what happened. So I looked over at this chassis for a reference, and I found the same thing. So wire cut off, going to nowhere. My best guess is that that was used during some testing phase of these chassis, back when they were in the factory. And when they were done with the testing, they simply clipped that lead off. I don't know. I don't know what else that might possibly be. I ended up removing all the components and wires from this whole corner so I could really get in there and tackle that rust. Pretty much got rid of all that. Now I'm turning my attention to this octal tube socket. That's for the horizontal output tube. It's looking kind of corroded, and I'd like to replace it if possible. I don't seem to have anything compatible on hand though, so I've been looking around online. Pretty much all the octal sockets I've seen that look similar mount a little bit differently though. They show them with on chassis where there's just a plain circular hole cut, and then there's kind of a wavy washer that locks them in from the backside. I think these are the same sockets, and in this case they chose to cut some teeth in the chassis metal itself and bend them up to accomplish the same thing as that washer. My only concern is the gap from this top edge to the bottom edge here the same. In other words, if I dig this out, will the new one just snap right in place? I guess there's one way to find out, and that's to pick some up. Luckily, I found a place that not only has these, but some other stuff I need, so I guess I'll just place an order with them. In the meantime, I'll keep working as best I can on the rest of the chassis. So now, as much as I try to plan ahead, I inevitably have to place more orders. So I got to place an order with one place to get some high voltage ceramic caps, and then another place to get octal tube sockets because I can't find one place that has everything I need. In the meantime, I'll continue working on as best I can. For example, I just cut out that nasty old filament dropper here, and I'm getting ready to rebuild this area. And then I'll move on to rebuilding these filter caps, which will take a little while, I imagine. Here's the top side of the chassis, which I've started to clean now. See, it's lovely and dirty up here, but this actually comes off really easily. And just use my fingertip and rub it off pretty well. But what works even better is a little bit of a cleaning product here. I'm using some Spray 9. I'd used 409 in the past, which works just fine. But I'd read about how well the Spray 9 stuff works online, but I just could never find any around here. It seemed to not be available in the Midwest. Until a few months ago, I was at Home Depot and they had a big mountain of this stuff and they were selling it dirt cheap, both in the spray bottle and 1 gallon bulk, so I stocked up on it. See, it does a fine job. Spray more on there and wipe it down. And over in this corner, not surprisingly, we've got corrosion on top just like we did below, so I'll use some navel jelly on that, like around in here. Also some corrosion on the flyback cage, also navel jelly on that. Now here's a closer look at that flyback. And it hasn't been recoated as thoroughly as I thought. You can see there's some chunks down below of coating that's come off. And it looks like when it was recoated, they only did the very top surface, just like right in here, and that's it. So just like on the holiday set, I'll pick and chip away at this carefully so as not to damage it, and then recoat it. But before I do that, as one of my viewers suggested, I'll let this run for a few hours to drive out moisture that may be inside there before I recoat it. I finished clamping up the side of the cabinet and then I stripped it. Still want to steam that side a bit to get some dings out. Speaking of which, I finished steaming the top. In general, I'm happy with it, except for a few areas where I think there's just wood material missing, like these actually are gouges, not just crushed wood fibers. So no steaming is going to bring that back because the wood just is simply missing. But I do want to get a nice level surface, plus these are kind of dark and I want to hide that. So what are my options? Well, one is to use some kind of wood filler, wood paste. But my experience with those is they just don't work that good unless you're dealing with solid wood or something that's going to be covered with a really dark color, so you just won't see it. But in this case, I'm going to be putting on a fairly translucent red mahogany lacquer. So if I was to smear some wood putty in here, I think it's just, if anything, going to accentuate the damage rather than hide it. I could just fill it in with like clear lacquer sanding sealer or shellac just to fill in these voids and build up the surface. But again, it's already dark, and if I put clear on that to fill it in, or with something like crystal lac, it'll still be visible. And if I just go straight from this to, say, mahogany grain filler, which I will be using on the rest of it, which is rather dark, it's really going to accentuate that. And you see a nice black line there. Well, there is one trick. I think I learned about it on this old house, which is to make like your own wood filler, which I just did here. What I'm doing is, I happen to have some mahogany veneer on hand from other projects. I just stacked up a few pieces to build up the thickness. And then I'm taking a little mini hacksaw here and just cutting across the grain to make some sawdust, some mahogany sawdust. And then I took a little bit of wood glue, tip of a toothpick, and I just dabbed a little bit in the holes there, rubbed the sawdust into it, and it does a real nice job of filling that in with real mahogany. Now, it's a little bit visible now, more than it will be when I'm done, I hope, because I haven't sanded it down yet. So it's standing up proud of the wood surface here. Once the glue sets up a bit more, I'll sand it down. And I don't expect it to completely disappear, but I think it will do a pretty good job. This sawdust here is a really good color match for the old veneer there. Alright, I just finished with the glue. Just a little dab just in the bottoms of those pits there. And now I'll sprinkle sawdust on. Alright, I'm going to let that dry and then sand it out. I finished filling in all the dings and dark marks with sawdust and glue. It dried, I sanded it down, and I think it looks better. Next up, I'm going to spray it with some shellac to seal it, do a little more sanding, and then apply some mahogany grain filler. I've applied a couple light coats of shellac to the cabinet, and now that it's dried fully, I'm going to sand it with 320 grit and then apply some grain filler. While I'm doing that, I also want to prepare a little test for the holiday cabinet. Got a great suggestion from Maynard Cat to take a look at some paper thin mahogany. This stuff is so thin you can run it through a printer, but it is real mahogany veneer with a paper backing so it doesn't fall apart. I found a guy on eBay selling a roll of it. It's just wide enough. It's 19 inches, whereas the section up here is 18 inches. And it's about 15 feet long, so I'm sure on this roll I can find a section that has a grain that matches pretty well to this. But obviously the color doesn't match too well. That's pretty much how raw mahogany looks. It's really not that red, so that's where the toner lacquer comes into play. So what I've done is I took a sample and I glued it to this board, and gluing it was also another little experiment. I used some diluted wood glue and found that it causes this veneer to wrinkle a bit. When I used a J roller, it kind of crushed it here and there, like in this section here. So I think contact cement will be the way to go with that. After the glue dried, I sprayed this with shellac, and now I want to put grain filler on this. After that, I'm going to try a couple different toner lacquers. I've got some red mahogany and some brown mahogany. I'm thinking the brown mahogany is going to be the way to go. So hopefully that will work out and I can finally wrap this cabinet up. This section here, I'll strip this. This is the only 2 bits or 3 bits here, here, and here. And all these sections of actual real mahogany wood. I'll strip those and refinish those. Touch this up. Just crud off the sides and do this section and probably the back section, and hopefully that will be it. I think you guys have seen me do this often enough by now. If not, go back and watch some of my older videos. In brief, I'm applying Constantine paste wood filler to the cabinet. Let it dry to a haze, scrape off the excess, repeat if necessary to get the surface perfectly smooth. After the filler dried to a haze, I scraped off the excess with an expired credit card. And that's going to be it for today. I've got to wait a good 24 hours for this to completely dry before I can continue on.